There are three things going on in this hard SAT geometry problem. And none of those three things that are going on is hard. The first thing that's going on is you're going to have to do some trig. SAT trig is always super easy. Second thing that's going on is you're going to have to deal with the Pythagorean Theorem. Well, you've been doing that since third grade, so that's easy. Third thing that's going on isn't even hard. It's just kind of annoying. It's should you reduce when you get a fractional answer? And the answer to that question, by the way, is always yes. Nothing hard here. It's just kind of a slog. Problem text says in triangle JKL, cosine K is 24 over 51. Angle J is a right angle. What's the value of cosine L? So the figure's not here. You've got to draw it. Draw it kind of big because you're going to have to draw on this figure. And you want what you draw, what you write, to be legible. Okay, so J is the right angle. Does not matter where you put K and where you put L. The cosine of K is 24 over 51. You're looking for the cosine of L. So let's write that down and circle it. Keep it in mind. And just start from the top. First thing you got to do is trig. Anytime you see cosines, tangents, sines, you always just want to write down SOHCAHTOA. You got to know what it means. So is for sines, ka is for cosines, and toa is for tangents. This problem just deals with cosines. Ka is adjacent over hypotenuse. And it means that you take the adjacent side of the triangle and you put it over the hypotenuse side. So they're telling you that the cosine is 24 over 51. Hypotenuse side is easy, right? You know what hypotenuse is. So that's 51. What's adjacent? Well, adjacent means next to. And which of the sides of this triangle is next to angle K? It's obviously this one. So that's 24. Okay, so that's the trig part, basically. That was easy. Now you're looking for cosine of L, and you're thinking, okay, cool, that's ka, that's just A over H. Again, you know the hypotenuse, it's just 51. And here's the crappy part. This is adjacent because it's the one that's next to it, and we don't know what it is. So what do we do? Well, it's a right triangle, you know two sides, so you know that you can use the Pythagorean Theorem. So it's just a slog, guys. It's just a slog. You write down the Pythagorean Theorem, and you say, okay, we're going to make the a squared side 24 squared. We'll make this the b squared side. We don't know anything about it. And then the c squared side is 51 squared. All right, 24 squared. What's that? That's 576. Still don't know anything about this b side. But we do know that we can square 51. We're going to get 2,601. Okay? So you're going to take 576 away from both sides, which simply means a subtraction problem on your calculator. And you're left with b squared equals 2,025. So how do you get to b? Know this. Take the square root of both sides, so that means just hit the square root button. And man, presto, b is a nice, easy number, 45. So what'd you just find? You just found the adjacent side, 45. And that means this here's 45. And now you're faced with the third part, the annoying part. Should you reduce? And the answer is yes, you should always just reduce. So you can see, hopefully, that you can divide 45 and 51 by 3. 4 plus 5 is 9. 9 is divisible by 3. 5 plus 1 is 6. 6 is divisible by 3. 45 divided by 3 is 15. 51 divided by 3 is 17. And so that's the answer. That's it. If you don't want to do that, you can just make an ugly decimal. You can divide 45 by 51. And you're going to get this nasty looking decimal that probably goes on forever. Looks like this. And then you say, oh man, what do I do? Don't freak out about it. There's two ways you can put this in. You could put in 0.8823. That's an acceptable answer. Or you could put in 0.8824. Three acceptable answers here. And the problem's not that hard if you just slog through it and treat each element that you have to do individually.